Okay, we're going to create slope fields from a differential equation. What you need to remember is that a differential is a derivative that gives us the slope of tangent lines. The only thing we don't have is, I'll give you an initial value later for a specific solution, but the slope field contains all possible solutions of that differential. Okay, so let's first draw a grid. And I want to scale it so that you can see it easier. Those are 1, 2, and 3. The slope is just defined by the points. Okay. So first we can start at 0, 0. Where am I going to plug that in? To the derivative right here. So you get 0 over 1, which is 0. Okay, so right here, you put just a flat little tick mark like that. That tells you the slope there is 0. What do you notice if any value of x is 0? What's the whole thing going to be? Yeah, 0, because it's going to be 0 on top, right? So any x value of 0 gives us a slope of 0. So just put a tick mark every half step. What if x is 1? Well, let's try one, 0. What do we got? 3, right? 3 over 1. Right. So at 1, 0, our slope is going to be, you put a tick mark, approximately slope 3. Mine could probably be a little bit steeper. Okay. What about 1, 1? Three over e squared, right? Do you know an approximate for that? It's about 1/2, right? So at 1, 1, we put a slope of about 1/2. And what about 1, 2? 7. Yeah, you get 3 over e to the 4th. What about 1, 3? It's 3 over e to the 6th. You see how it's flattening out?
Oh my god. So is it like goes up kind of like?
Basically, it's tending towards 0. Okay. What do you think is going to happen as we go down here?
It's gonna get steeper.
It's going to get steeper. Okay. Okay, so we're starting to see some slopes start to form up, right? What about 2, 0? 12 over 1? All right, so what are we going to probably see? These get steeper and steeper, right? As we go out. So we're noticing patterns here, right? And so you can see how these lines are kind of coming together. What we're going to see with this slope field is that it does this number. So we're going to have some dash marks go in this direction, and these are all going to be like asymptotes. It's going to be like an asymptote, okay? So let's try 2, 2. And what do we get? 12 over e to the 4th. What's that approximately? Wrong again, Ben. So about 0.25-ish. Hopefully it's wrong. So you can continue this process. It's kind of tedious.
Make like a cool, like,
but what it makes is kind of a, so if we did 3, 1, 3, 1 is a little bit steeper.
It's kind of like when you watch fish swim in the ocean in that huge group. And they can, like,
Yeah, exactly. 2, 2. I did. Oh yeah, I put it in the wrong spot. That's what the problem is. That was 2, 1 that I put on here. What we're going to see is this kind of heads. So you see,
Justice was served, Daddy. I don't like this and like
No, I doubt that happened.
keep focused. So if we did all the rest of these down here, we would see them become much more vertical lines, right? In here, we see the same thing. I don't want to take you through all the math because I know you can do the arithmetic. What we see here is that as we head out, these tick marks kind of curve into these ones. So you can kind of see a general, this one should be like that. And so you kind of see the flow of that solution, right? So this looks like a general solution that does something like this. So that's a slope field. It's plug and chug. If you have the derivative, you can generate a slope field, or the differential, you can generate a slope field. Sometimes you're going to be asked to generate a specific graph on that slope field for a specific solution. So it would say something like graph the solution to
dy dx for y0 equals 1/2. And that's where we'll be using the skills that we've been learning the last 2 days. Okay. So let's go ahead and do that just to reiterate. So this is our differential. I'll separate the variables. And integrate. You can get the 1/2 e to the 2i by u substitution, or just know the chain rule in reverse. All right, so natural log and then divide by 2. You with me so far?
No, but.
I know I was going.
Is that Y part of the E carrot thing? Or is it on?
Say when.
Right there?
Here,
Yeah.
it's e to the 2y.
Okay.
It's a part of the exponent. Plug your initial condition in. Yada, yada, yada. C is e over 2. So our specific is that right there. Okay, the hard part is putting it on your slope field. But all you need really is 1 point. And you can go with it. So if x is 0, y is 1/2, right? So I know that it goes through there. But I can already see the general pattern from my slope field. It's going to do this. There's our specific solution. You just follow the dash marks.
So do you just plug numbers into it, or what?
I just found 0, 1/2 as a point, right? And then all I have to do is follow the slope field dash marks. See how right here the
Oh.
slope is about 1, so I need to have a slope of about 1. Right here the slope is 0. So you're following the slopes to do a specific graph of that solution. So this is a specific solution. The slope field shows the shape for all solutions, moving up or down.
So you get one
It's
point,
testing me.
always do it based on like that.
What?
So that graph right there is 3x squared divided by e to the 2i.
Yeah, that's the specific solution.
Okay.
Here's a better picture of it. What I'm going to hand you. There are 4 examples in here, I believe, maybe 5. So if you need more examples, I have some here for you.
Just a reminder, any student interested in playing football next year needs to meet with Coach Leonard in the library at lunch. Come get an office pass, grab your lunch, and go to the meeting. Also, there's a junior class committee meeting, and if you don't want to,
I'm not going.
it goes like down and like, it goes like, I think that's why I eat like this, is like ridiculous. Like, each person-
Yeah, I have a packet for you to take with you. These are the notes, with extra examples for you, just in case. So, it's got an extra pretty picture for this one that I just showed you.
Even the AP are doing tomorrow as well. Prom committee will be meeting in Miss Whitman.
We're gonna work on this packet tomorrow. Do some of it tonight. We won't finish it. It'll all be due Tuesday. Solve the AP problem.
I want to corn dog.
Okay?
We're not on the
Really did that day. There is something.
Put a little bit of time into it tonight. We'll work on 3 more tomorrow. Tuesday. AP spiraling is due Tuesday, and so's the packet.
What's due tomorrow?
Nothing.
So we don't have homework tonight?